Last week, we found out the site characteristics of Cctv HQ and how the foundation of the skyscraper in the sedimentary layer was constructed using the pilot raft foundation. This week, we will find out how the concrete pouring and columns for the base of the building were constructed. Construction of Cctv began on September 22, 2004. The following months, it excavated 870,000 cubic meters of soil from 130,000 square meters of land. However, due to traffic problems and regulations in Central Beijing, the work was only possible at night. Pilot raft foundation was upright for stable support of the building. After installing the pilot first, concrete pouring work for the raft was started. In the construction of Cctv, about 130,000 cubic meters of concrete was used for the foundation of the tower and podium. Concrete with a depth of 4.5 to 7 meters was used for the lift of Tower 1 and Tower 2, respectively, and 41,000 cubic meters and 31,000 cubic meters of concrete were used. Continuous drilling was performed for up to 57 hours, and through this, stable support of concrete was secured by minimizing the formation of joints formed by separatory curing concrete. Cracks due to the heat generation of concrete had to be considered when pouring large amounts of concrete. Heat generated by the hydration of concrete escapes from the outside but cannot escape from the inside, resulting in temperature differences between the inside and outside. As a result, the interior expands compressive force can be generated, but external contract and tensile load can occur, resulting in cracks in concrete. To prevent this, a concrete pipe cooling method is applied. In this method, the pipe is installed before pouring concrete, and the concrete is poured so that it can be wrapped around the pipe. After that, water is sent through a pipe to reduce the temperature difference between the inside and outside of concrete. This process is as follows. 1. Place the pipe inside the concrete and pass it through well. 2. Use pressure to expand the diameter of the pipe. 3. Place concrete at this time. Make sure that concrete completely wraps around the pipe. 4. Remove the pressure and connect the pipe to the cooling system before the concrete is set up. 5. Send cold water to cool the concrete afterward. 6. Once the concrete is set, the pressure is removed to contract the pipe and remove it and fill the hole with concrete. The Cctv headquarters building is 234 meters high and the tower part is inclined at 6 degrees. So it was not possible to use the method of building the building by having a tower crane move vertically. Therefore, the Cctv headquarters building was constructed using 2 tower cranes. 1. Install tower cranes 1 and 2 on the ground. 2. As the height of the building increases, the crane moved vertically. 3. At this time, as the building rises due to the 6 degrees tilted tower, tower crane number 2 cannot reach the end of the building due to the limit of horizontal distance. 4. Therefore, crane number 2 is dismantled using crane number 1. 5. Using crane 1, move the building horizontally in the direction in which it is tilted and reassemble crane 2 in a new location. 6. Cranes 1 and 2 resume work again. 7. This process includes a total of 14 horizontal movements and 4 vertical movements. The pillars used in CCTV headquarters are SRC structures. Structure is a type of composite structure that complements the shortcomings of reinforced concrete and steel frame and takes advantage of their respective strengths. It is a structure in which reinforcing bars are placed around the steel frame and concrete is poured to function mechanically as one body. SRC composite columns have two advantages: load carrying capacity and ductility or toughness. Load capacity is achieved by combining steel and concrete, so that the concrete prevents buckling of the steel and the steel restrains the concrete to keep it under triaxial compression conditions. Ductile capacity mirrors the improved ductility of concrete, improving column performance. Due to this advantage, SRC composite columns have superior performance compared to existing RC columns. If you look at the following graph, you can see that the x-axis is strain and the y-axis is stress, and the yield stress, ultimate stress, and strain to the fracture point of the SRC column are greater than those of the other columns. According to research results, the performance of SRC columns varies depending on the arrangement and type of internal steel, with compressive performance improving by 50 to 70% and tensile performance improving by 400 to 800%. SRC columns have superior structural properties compared to RC columns. Next week, we will look into the retaining walls of the building that prevented the building from being destroyed by the water pressure of underground water. In addition, we will start the structure of the building that made it possible to support the unique appearance of CCTV. We will look into the external structure of the building, the diamond grid, and the welding that connects the steel frames.